Okay, so we are going to do domain and range today. If we remember from our review, we know that domain is what? Okay, it's all of your x values. Very good. Okay, so a set of x values. Your range then is the set of y values. Okay, if we look at graph number 1, okay, and look on your paper, it's a little easier to see probably than my screen. Let's go ahead and list the ordered pairs. Let's go from left to right. Whoops. So, Mariah, what's the first ordered pair from left to right?
Like off the graph.
Yes, what's the point, the ordered pair? No, you're going all the way to the left. This point right here.
Oh, okay.
7 what?
-7.
-7 what?
1.
Okay, I need a Mariah, guys. Listen to who I'm talking to. Candace, tell me the next one. Caitlin, you get ready for the third one. Nick Brunick, get ready for the fourth one. And Savannah, you can do the fifth one. Okay, so what's the next point? Candace? Nope, all the way over here. -3. Is it -4 or +4? Is it going up or down? +4, right? Okay, what's the next point?
0, -4.
Okay, 0, -4. What's the next point, Nick Brunick?
0.
Okay, 2, 0. And the last point, Savannah?
6, -7.
6, -7. Okay. All right. Let's go back to this row here. Kira, what's the domain then?
Does that have to be like in?
Just tell me the numbers, because
Okay.
here's the yeah, it needs to be in order, but here's the format. D dot dot and then your brackets, okay?
So you want me to say it from the list of
Yeah.
Okay, so it'll be 0 or -7.
-7,
-3.
-3,
0.
0,
2 and 6.
2, and 6. It's already worked out for us because we went which way? Since we went from left to right, the x values are already set up. Okay, now there's a couple of different schools of thought here in how you write range. Okay, you can also write range from least to greatest, or some people will do range because we're talking about domain and range together. Well, they'll do range where -7 goes with that number, and they have it in that order with the same number. Okay, so let's just go least to greatest though. So range.
-7.
Okay, -7, -4, 0, 1, and 4. Okay? Is this a function?
No. Well, it passed the VLT.
Okay. Yes. Why?
It passes the VLT.
It passes the VLT, or the vertical line test. Okay, so what Nathan's saying is if I draw a vertical line through these points, there's not going to be a vertical line that has more than one point on it. Okay? Or also, what's the other reason? Think back to what was a function. How do we know something's a function? The x's don't repeat, right? Look at your x values. They're all different. Okay? So that's how also you know that it's a function. What kind of function is this called? What? Nope, it's not a quadratic.
Linear?
It's not a linear. Does it create a line?
No.
No.
We're thinking about two different things we talked about. It's been a while since we talked about these. Talking about concrete or discrete. Discrete. How do you know it's discrete? Tells you in the question.
Because the graph is just separate points.
Yeah, because it's separate points, right? Remember, concrete is when we say, okay, we can take half points and all that stuff. Remember? It's been a long time. Make sure you review that because that will absolutely show up on the STAR test at the end of the year. Okay, concrete is basically when you take a line and you say, okay, that graph's concrete because it takes every point. No matter what. Every point that's on that line, you're good to go. This is discrete because you have separate points. It's only allowing for those specific points. Does that make sense? Okay.
Oh, discrete. I said concrete.
Okay. Graph number 2 is of a, what kind of function now? Linear. That one's easy. Linear function. We know the line continues in both directions, so what is happening to the x values and the y values? What is happening to them? That's why y'all are missing problems on that last homework assignment. It's because y'all aren't reading the question for what it's supposed to be. What is happening to the x and y values?
They're increasing or decreasing.
They're increasing and decreasing, so they are what? Continuing on, how long? Forever. They're going on and on forever. Okay?
So continue.
Right, however you want there. Go on forever, continue on forever. So now, Jefferson, we could say the domain and is what?
It's all real numbers.
Is all real numbers. Brayley, the range is also what? All real numbers, because it goes on and on forever. Since a graph has no breaks, it is said to be... I'm sorry, it's not concrete, it's continuous. Continuous. Did I say concrete earlier?
Yes.
My bad. I meant continuous. Well, there's no concrete anyways, or it's continuous and discrete. My mistake. Concrete. I was thinking of something else. All right. That's funny. That's awesome. It's continuous and discrete. My bad. There you go.
When did you get concrete?
I don't know.
You kind of mixed it.
It's because they.
I don't know where I got concrete from. Yeah, I guess so. Maybe
I
that's
was
it.
trying to figure out why concrete was related to that. I was like,
No, I'm sorry. And I didn't even think twice about it. All right, here we go. Number 3. Graph of number 3 gives us part of a line. Okay, or a, what is this? Segment. Not segment, segment.
Yep.
Hey, we'll forgive you since I said concrete for segment. Okay, it's a line segment. What is the smallest value of x?
-1, 2, 4. -4.
Right. My x value, and here's the way I show students how to do this. If you take a segment, segments are great because you take a segment and draw it to your x value. And then draw it to your other x value. Okay? Now you can see that all my x values are in between here and here, right?
Yep.
Okay? So my smallest one has got to be the one furthest to the left, which happens to be 1, 2, 3, -4, right? So my smallest x value is -4. What's my largest one?
5.
Okay? 1, 2, 3, 4, 5, right? So my largest is 5. So the domain is a set of all x values between what?
-4 and 5.
-4 and 5. Now this is where students struggle. If you set this up just like this, you're going to be okay. Here's what you do when you write the domain, because this looks a little weird. You're going to put domain, everything's the same here, okay? And you're going to put the smallest number, x, I put -5. Smallest number, x, and the largest number. Okay? Now, I'm not done yet, but I put the smallest number, x, and the largest number. What do you know about x compared to the smallest number? What about all these values compared to that smaller number?
They're larger.
They're all larger, or you could say they are greater than. So x is greater than -4. Does it equal -4? Look at your paper again.
Greater than
Yes, it equals number 4. How do I know? Because the dot's colored in. So x is greater than or equal to -4. How does it relate to 5? You could say it's less than.
Oh, you wrote less than.
Oh my god.
Yeah, but if you like flip
I'm sorry, what?
Wait,
That's
never mind. You're good.
okay. Now again, remember, look at how it's written compared to what I'm saying. I said x is greater than -4. Yes, did I write a less than sign there? Equal to? Yes, because that -4 is less than or equal to x. But you're thinking about everything in terms of x. And then x is less than, but not equal to 5. How do I know it's not equal to 5? Yeah, because it's not colored in. Okay, it's not colored in. We're going to do the same thing with y now. What's the smallest value of y? And you can do the same thing here. Go to your y values and draw a line to that point. Go to your y value to the highest and draw a line to that point. And so the smallest y values, all my y's are going to be in between here, right?
Mm-hmm.
So I'm going to start here at 0. I'm going to go down to -1, 2, 3.
Question. Wouldn't the greatest
Or 2, excuse me.
the greatest x value would be 4 because you can't be on the dot.
No, but can it be 4.99999?
Yeah.
Okay, so how are you going to write that? You write that by saying less than 5.
Oh, okay.
Okay?
Okay.
Okay, so we said the smallest, the smallest y value is what? 1, 2, -2. Okay? The largest y value then is 1, 2, 3, 4, 5, 6, 7. My line's not very straight, is it? 7. Okay? So then the range is exactly the same way. Put your smallest one first, -2. Put y, and then your largest one, 7. Okay? And then now, how does y compare, how do all the other y's compare to -2? How does the y's compare?
They're greater than.
Then greater than. So that means -2 has to be what y? Less than y or equal to y, right? What about compared to 7? Y is what? Less than 7. Okay, this takes practice to write like that. So it's very important that you're doing your homework, not rushing through it, but you're taking your time to do your homework the right way, because this is one of the harder things to do, and you'll do this again in MMA or Algebra 2 as well. Okay, so you need to be prepared for that. Is this graph concrete, discrete, or continuous?
or continuous.
Can I have halves? That's the easiest way to look at this. Can I have fractions? Yes, I can have fractions, right?
How?
Because this number right here is a fraction.
Oh,
It's in between 2 points. Basically, it's not broken up and it's not separated, right? And so it's continuous. Okay? All right, moving on. Let's look at number 4. What is the smallest x value for the graph of number 4? So I'm going to go to my x value. And here's 1, right? Can I draw a line on the end of this one? No, why not?
Because it has an arrow, so it goes on forever.
It goes on forever. So is there a smallest value for x? No. So there's none. Oh, wrong one. Sorry. Okay, so there's none. There's no smallest value. You're not going to have to answer this question a lot. This is just kind of the setup. What's the largest value of x?
4.
Okay, so 1, 2, 3, 4, right? Okay, so we're going all the way to the right. So the largest value of x is 4. Okay, let's go ahead and drop down here to domain and do domain right now. So what can you tell me about the domain based on what you learned last time? What is your domain?
All your x values.
So x is something. What is x? What are all your x values? All your x values are less than 4. Are they equal to? No, because why?
This is not filled in.
Okay. Yeah, the circle's not filled in. But look here. Your x values, like Jefferson said, go on and on and on forever. So that means that all of your x values less than 4 are okay. Okay? Let's go to y. So on your y value, What's your smallest y value?
2.
Okay? So your smallest y value is 2. So here, 1, 2. What's your largest y value?
There is none.
There is none.
Yeah, can I put a top on this? No, why?
Because it goes on forever.
Yeah, because the arrows go on forever. So then you can say there is not one. So there is no largest value. So your range then is what? Y, very good for changing the variable, is what? Greater than 2. Is it equal to? No. It's greater than 2 because all the numbers from this line go up, right, and get bigger. That's why it's greater than. That's why it's good to draw these lines. It helps you be able to tell, okay, all the numbers of y values above that line are going up, okay? Let's look at, is this concrete or, golly, is this discrete or continuous? Continuous, okay? How do I know it's continuous? Because it can have what? Fractions, right? And it goes on and on, right? Okay. Let's look at our next one. What is the smallest value for x in graph number 5? Yeah, if this is 0, 1, 2, 3, 4, 5, right? -5. Okay, what's the largest value for x?
3.
Okay, so 1, 2, 3, right? What's the smallest value for y? Not there. Stuck on there. Okay, -3, 1, 2, 3, right? What's the largest value for y? And notice how it's not endpoints now. Like all these have been an endpoint of the graph. Now this is in the middle. This is the maximum, right? Okay. So now you have where's 0? 1, 2, 3, 4, 5, 6, 7, 8, 9. So our maximum is 9. Our largest value, is 9. Okay. So let's do the domain now. So how's the domain go? -5 x.
Less than or equal to.
Oh, it's in my. I bet it's in my jacket. Oh no, it's right there. Okay, so -5 x and.
What happened to the screen?
Oh, did you unplug it on accident? Okay, so -5 is my smallest x, and what's my largest? 3. So how does x compare to -5? Okay, so -5 is less than, right? Now, x is greater than all them, right?
Can it be
Okay.
less than or equal to?
Okay, is it equal to? No. Is our dot colored in? I can't tell anymore.
Yeah, it is.
Okay, our dot's colored in, so it must be equal to. Okay? What about 3? X is less than 3, right? Okay, so x is less than 3. Is it colored in? I can't tell anymore. So it must be less than or? Equal to. Okay, what about the range? What are our numbers? -3, y, 9. Okay, so how does y compare to -3? It's greater than, so y is greater than or equal to. And again, in this case, -3 is less than or equal to y. How does it compare to 9? Yeah, y is less than. Is it equal to 9? Is the dot colored in? I don't think it is. Yeah, it's not.
No, it's not.
Okay, so it's just less than. Is this continuous or discrete? Continuous, right?
I did that the whole time.
Okay. What's the domain and range for this one? We're not going to do all the lines. You tell me now.
The domain. 7 to -7
Pretty sure it's 6.
-6, x 0.
I got -4. Oh, 5, 6. Yeah, -6, x, 0. Okay, so how does x compare to -6? Okay, listen. Okay, let's go ahead and finish up. We got cut off in class, so we ran out of time. So I want to go ahead and finish up this one here. It says, what is the domain and range for the graph at number 6? Again, if we were doing what we were doing earlier in class today, the domain is the x value, so we want to go to see where our furthest left x value is. But one of the things you're going to notice here is on this particular thing, look here. You have arrows on these, okay? And since you have arrows at the end of these parabolas, you know they're going to continue to go up. And as they continue to go up, they're going to continue to expand because they're not just going straight up, they're going at an angle outward. So they're going to continue to expand. So does it ever stop going to the left? Does it ever stop going to the right? Well, the answer on that would be no. So we actually need to take this away. We started talking about this in class. I think we were rushing and made a mistake. And so what we realized then is that since it always keeps expanding to the left and right, what we really have is all real numbers for a domain because there's no endpoint to the right or no endpoint to the left. Okay, so let's look at range now. What's our lowest range value, our lowest y value? If you draw your line right there, you're going to see the lowest y value is going to be -1. Okay? What's our greatest y value? Can I put a cap on this y value? Again, if you notice, there's arrows here, meaning that it's going up and never stopping. So I can't put a max on my y value. So what I would say then is that y has to be greater than or equal to -1 because that's all I have. I have no minimum value. The only time you put y in the middle of two values is if you have a minimum and a maximum. In this case, I only have a minimum. So, is the graph continuous or discrete? Well, it is continuous because we can have halves. Okay, it's not broken down into separate pieces. Okay? All right. Let's look at the next one. It says y equals 5x. Okay? If we want to help ourselves on this, we could go into our calculator and we can hit y equals and graph that. But what you're going to find out is this is a linear equation. And for the domain on linear equations, if the line goes on forever and ever and the line is slanted, meaning it has a slope, then the domain is going to be all real numbers because it's going to keep going across and expanding out to the left and to the right on the x values. So linear equations have domains of all real numbers. And in this case, is it going to keep getting higher and higher? Is it going to keep getting lower and lower? Yeah, again, it has a slope, so it's going to happen. So again, you have all real numbers. Is the graph continuous or discrete? Well, you can have halves. There's no restrictions that say you can't have halves, so it is continuous. And if you have questions about this one, please make sure you come see me, and I will walk you through the calculator process, and I will show you the graph on the board or something like that, okay? All right, number 8 says Craig received a $15 gift card to download music for his MP3 player. Each song costs $1.50. Okay, so if each song costs $1.50, then what you're going to have is an equation that says y is equal to 1.5x, right? Now, this $15 gift card is important if we're trying to solve something, but unfortunately right now we're not trying to solve anything. We're just trying to figure out how much each song cost. Okay? So, with that being said, is this equation right here, is there an endpoint? Okay? Is there an x value that's a minimum? Okay, and remember, what does x represent here? X represents 1.5 per song cost, right? Well, can you buy a negative song? No, you can't. So your domain has to be x is greater than 0. Can it be equal to 0? Yeah, it can be equal to 0 if you don't buy anything, right? But it's got to be greater than 0. What about your range? Okay. Well, let's think about this. If 0 is our lowest number, we can plug that in here where the x is, and we can solve for y. So if we're using our 0 as our lowest x value, what's going to be our lowest y value? Yeah, y is going to be greater than or equal to 0 because our lowest y value would be 0 as well. If I bought no music, then I have no total, right? Because y represents the total. Okay, now this is an interesting one. If I graph y equals 1.5x, just like that, I'm going to have a straight line, right? But I'm not graphing the equation 1.5x. Now I have to look at the scenario. On this scenario, it's talking about music. Can I buy half a song? No. Since I cannot buy half a song, this function is going to be discrete. Okay? And again, if you have any questions on that one, please come see me and we'll talk more about it in class. Okay? All right, and that pretty much wraps up this section. Hopefully you'll understand. Again, this is a kind of a tricky section, so make sure you watch the video multiple times if you need to, and make sure that you are asking for help when you need help. Okay? As always, come see me after school and pass from 4 to 5 or in the morning before school starts. If you have anything else, just write it down. Have a great night.